Hi students, welcome to the next session. In today's session, we will discuss determinants synopsis. Already in previous session we finished matrices synopsis. Today we will discuss based on some PU concepts and some JEE level concepts also. Determinants first. What is the meaning of determinant? For a square matrix, a number, that number can be real or complex, associated to it is called a determinant. For every square matrix, there is any number which can be associated with A, that is called a determinant. Determinant of, for example, A matrix if you take, determinant of A denoted by det of A or det A, a delta symbol, or sometimes they use delta symbol also. A number which is associated in a square matrix, that is called a number what? Can get real number or complex number, that value is called an determinant. That means determinant is possible only for square matrices, not for rectangular matrices. Now in this, for example, you want to find how to find the determinant of 2x2 matrix. For 2x2 matrix, how to find determinant? For example, a matrix A is given like this: A, B, C, D. That A we need to find. That of. This is a symbol. Don't read modulus. It is a determinant of. That of A, B, C, D. Determinant can be real number, positive or negative. But modulus is not negative. It is always a positive value. So how to find this one? Simple. Like this. AD minus BC. AD minus BC to find the determinant of 2x2 matrix. Next, coming to third order is given. Third order determinant. How to find the determinant of order 3x3? Already we discussed in PU. For example, the det A is given like this. Det A equal to det of A11, A12, A13, or simple easy purpose if you take condition wise A1, B1, C1, A2, B2, C2, A3, B3, C3. You want to expand this to find the value of determinant. How to find? Here, finding determinant we can do along any row or any column. The value of determinant remains same only, no changes. For example, if you want to expand this along first row, before expanding, you should know the sign of each row or column. Here, how to identify sign plus or minus is very simple logic. Here, first row, first column, first row, second column, first row, third column. Now here sign is actually plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. Now as for that, now we are expanding along R1. How to expand this? Plus A1 into, by deleting its row position and column position. This A1 is lying in first row, first column. By deleting its row and column, what remaining elements? B2, C2, B3, C3. It is reduced into second order determinant. B2, C2, B3, C3. Here plus, now here minus. Minus. What is the element is there in that position? B1. Now again, B1 is lying in first row, second column. First row, second column delete. What remaining elements? A2, C2, A3, C3. A2, C2, A3, C3. Last sign is plus. Element is C1 into C1 is lying in first row and the third column. Deleting what remaining? A2, B2, A3, B3. A2, B2, A3, B3. We know how to expand a 2 by 2 determinant. Just AD minus BC. Now here A1 into B2 C3 minus B3 C2 minus B1 into A2 C3 minus A3 C2 plus C1 into A2 B3 minus A3 B2. Here simple, that's why I got like this. Generally if you take numbers, you will get a single value only. That can be sometimes real number or sometimes complex number. Here. So this is the expanding for 2 by determinant and 3 by 3 determinant value. Now next, coming to properties of determinant. Properties of determinant. This property is using to simplify certain type of determinant values. Directly expanding the simplification is very difficult. In that case, we are following these properties. In this first property, if all rows and columns are interchanged, the value of determinant is remains same. If rows or columns of a determinant interchange, then value of determinant unchanging. That means simple logic. Transpose of determinant value and original determinant value both are same if we interchange the rows or columns. That meaning what? Transposing only. So I already proved in PU, just remember the property. Next, second property. If you interchange any two rows or any two columns, the value of determinant sign changes. If any two rows or columns of a determinant interchange, then sign of determinant changes. Interchanging two rows means what? For example, you are applying like this. R1 by implies R2. Or columns you want to change. C1 by implies C2. If you interchange any two rows, any two columns, for one interchange sign will be changes minus. Plus will get negative. Minus 1 will multiply for the determinant value. So it is a simple logic. If any two rows or any two columns are changed, then sign of determinant changes. Next, third one. If any two rows or any two columns are identical means corresponding elements are same. If any two rows or columns are identical, nothing but corresponding elements are same, then value of determinant is 0. Example, let's simple example here. 3 by determinant. I will take first row A1, B1, C1. Second row A2, B2, C2. Third row again I am taking A1, B1, C1. Now which row corresponding elements are having same? First row elements A1, B1, C1. Third row A1, B1, C1. Generally means we need to expand. Without expanding, by using this property we can find the value of determinant as easily. What any two rows or any two columns are identical, then the value of determinant is 0. Here R1 and R3 are same. That's identical. R1 and R3 are identical. When two rows or two columns are identical, value of determinant is what? 0. It is simple use of these properties. Next, fourth property. If each element of any row or column multiplied by a constant k, then value of determinant gets multiplied by k. That means along any row or column, if you multiply any constant, then the value of determinant gets multiplied by that constant. Simple meaning, we can take common factor out of any row or column. For example, there is a delta like this: A1, B1, C1, A2, B2, C2. Here I am taking some KA3, KB3, KC3. From any column or row, we can take some common factor. A simple logic: if each element of row or column here what? Along which row constant is multiplied? Along row 3. Now row 3 is a k is a common multiple is there. We can take out that. Then the value of determinant gets multiplied by these constant k. What here? Delta equal to, you take k common from row 3. A1, B1, C1, A2, B2, C2. So what? A3, B3, C3. If you expand this, the total value gets multiplied by constant k. Next, property number 5. If some or all elements of any row or column having sum of two or more terms, then determinant can be expressed as sum of two or more determinants. That means if any row or column having sum of two or more terms, that determinant can be split into two or more determinants. For example, now the delta determinant is given like this: A1 plus some D1, A2 plus D2, A3 plus D3, here B1, B2, B3, C1, C2, C2. Here, some or all elements of any row or column having sum of two or more terms, then determinant can be expressed as sum of two or more determinants. Here, row 1 having sum of two elements, A1 plus D1, A2 plus D2, A3 plus D3. This can be split into two determinants. How? In the first row, first elements are what here? A1, A2, A3. A1, A2, A3. Second row, third row having single element, that will be repeated for both determinants. B1, B2, B3, C1, C2, C3 plus what are the second elements in first row? D1, D2, D3. Second row, third row remains same. That means after splitting the two determinants and original determinant value both are same only. After dividing into two parts and the original determinant value is both are equal. Next, sixth property, last property. If each element of any row or column of a determinant equi multiplies of any other row or column are added. Again, I'll explain. Select property. Then value of determinant unchanged. That means each element of any one row or column of a determinant equi multiplies of other row. Equi multiply means we have to multiply with any one constant fixed value. That two rows are added or two columns are added, then the value of determinant remains same, means not changes as it says. How? Simple logic. For example, I take like this R1 plus some equi multiply means K multiply plus R into R2. Each element of any row equi multiplies of other row or column. So other row equi multiply means what? Equally multiply with K constant for second row. Both are added even though the value of determinants is same only. Similarly, you can apply for column operation also. For example, C1 plus K into C2. After applying this type of operations also, the original determinant is not changes. That is the property number 6. Next concept, area of a triangle. Now, how to find area of triangle? By using determinants concept. Already area of triangle, half into basic height and vertices form also there. But by using a determinants concept, how to find area of triangle? If three vertices A x1 comma y1, B x2 comma y2, C x3 comma y3 are vertices of a triangle, then area equal to half into depth of first vertex. What is the vertices values are there? x1, y1, second point x2, y2, third one x3, y3. Now the third column take it as 1 elements. If you expand this along any row or column, you will get the area of triangle. While expanding determinant, we need to consider modulus. Reason, area of triangle is always positive. And few more points we need to identify here. What here? If area is given, we need to take both positive and negative, plus or minus. Reason, for example, area given, area for example 4. Area given means what? Actually after expanding we get some modulus. Modulus of some value will come. For example, some 2k, mod of 2k. So total value we got 2k. equal to what here? 4. Is a k is an unknown value. Now to take that side, mod of 2k equal to 8. To simplify this, we need to remove this modulus. So because mod x equal to some k means x is can be either plus or minus, either positive or negative. That's why 2k becomes what here? Both plus or minus 8. So when the area given, we need to take both positive and negative to find the unknown value. Next, if given points, if a comma b comma c are collinear, collinear means all points lying on same line. In that case, area of triangle becomes what here? 0. So if the ABC are collinear, then area of triangle is 0. So the main points we need to follow in this by using area of triangle concept. Next, coming to next concept, how to find the minors and cofactors. How to find minor of a determinant, a given determinant. Minor of an element, a given determinant, is a determinant by deleting or eliminating. By deleting its ith row and jth column. That means the element lying in which row or which column. By deleting that, we need to consider determinant value. For example, the delta is given like this, overall delta A11, A12, A13, A21, A22, A23, A31, A32, A33. You want to find the minor of any one element. For example, you want to find minor of A12. How to find the minor of small a1? Small a1 means clearly element of the determinant. What I said here, minor of an element of given determinant is a determinant by deleting its ith row and jth column. That means its row and column. Minor of any element denoted by mij. Aij is an element means its minor is denoted by capital Mij. Here what is the element? Small a12. Its minor is denoted by capital A12. How to find this? Minor of an element of given determinant is a determinant. Take it by deleting its row and column. It is lying in which row? First row. Deleted. Which column? Second column. After eliminating these two, first row, second column, what remaining elements? A21, A23. A21, A23. Next. A31, A33. If this one is clearly 2 by determinant, easily you can find it. How to find? A21 into A33 minus A31 into A23. Now minor also will get finally value only, a number will get. All have understood how to find minor of an element. Next, cofactor of an element. In the given element. How to find cofactor of an element? Cofactor of an element denoted by Cij. Or sometimes they use capital Aij also. Small a is an element, capital M is a minor. Cij or Aij, capital Aij is nothing but which one? Cofactor of an element. How to find this? Very simple. Minus 1 whole power. I means row position, J means column position into its minor. Now how to sign is depending on, if I plus j is odd, you will get minus. I plus j is even, you will get plus. How to get? Very simple. A11, 1 plus 1, 2 is even. Even means sign what you get here? Plus. Here 1 plus 2, odd, that's why minus. Plus, minus, plus. Minus, plus, minus. Plus, minus, plus. That are the sign for each element to find the cofactor of an element. The difference between minus and cofactor is minus just by deleting its row and column only. Here cofactor just we are multiplying with that minus. That is the difference between minus and cofactors. Here I will find the minus and cofactors of an element. If you want to just discuss one example, how to find the cofactor. Same cofactor of from the same determinant only, A13 you want to find. Now A13 clearly lying in first row, third column. That minor is written by capital A13 or C13. Clearly, no need to write this formula always. It is only for understanding purpose. A13, 1 plus 3, sign what here? Plus. Plus into its minor, M13. How to find M13? By deleting its row, first row, third column. First row, third column, delete. First row, third column, delete. Remaining what? A21, A22, A31, A32. I simplify this what we get. A21 into A32 minus A22 into A31. These are finding cofactor of an element. And in the concept of area of triangle, one more point here. If how to find equation of line by using determinants concept. For example, line will tell you only 2 points. Any 2 point tell you. 2 points means, for example, A point and B point, some 1, 2, some 3, 4. In geometry, we use 2 points formula, but you should not use. You have to use only determinants concept. The equation is clearly in the form of variables x and y. That is a locus of point, that is P, x comma y. Now this combination of these 3 points, all 3 points lying on the same line, then the points are collinear points. Collinear points means what? Again here using which concept? Area of triangle is 0. This point they won't give you question. Reason? The last question like this what? Find the equation of line having passing through the point A and B using determinants. Determinant means we need 3 points compulsory as per formula. Another point what? Locus point. That is any point lying on the line, that is x comma y. A combination of these 3 points are always lying on the same line. Now all lying on the same line means collinear points. For collinear points, area of triangle is 0. Same concept we use to find the equation of a line. Next, singular matrix. What do you mean by singular matrix? A square matrix said to be singular if det A equal to 0. Determinant of square matrix is 0, that is called which matrix? Singular matrix. Next, non-singular matrix. Same, a square matrix said to be non-singular if det A is not equal to 0. Equal to that value is 0, that is singular matrix. That is not equal to 0 means non-singular matrix. And how to find inverse? Inverse of a matrix. Now inverse of a matrix, there is a formula. A inverse equal to 1 by det A into adjoint A. Now before this, What is meant by adjoint A? We learn it. Adjoint A means adjoint of a matrix. We know already how to find cofactor of each and every element. The combination of all cofactors of a matrix is called cofactor matrix. Transpose of that matrix is called an adjoint of a matrix. For example, I'll explain once. Transpose of a cofactor matrix is called adjoint of a matrix. For example, a matrix A is given like this. What? For example, A1, A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the matrix A. Already just now we discussed for each element what is my cofactor matrix? Cofactor matrix. Cofactor matrix nothing but for each element we need to find cofactor. But all replacing in that place, that is called a cofactor matrix. For small a1, what is a cofactor? Capital A11, capital A12, capital A13, A21, A22, A23, capital A31, A32, A33. If you apply transpose for this matrix, that is called a adjoint matrix. Adjoint of matrix is denoted by ADJ of A. This is a symbol for adjoint of matrix A. How to find transpose of this matrix? A21, A22, A23, A31, A32, A33. Apply transpose for this. Transpose means what? Interchanging rows and columns. Transpose means what we get? Row changing to column. Capital A11, capital A12, capital A13. Capital A21, capital A22, capital A23. Capital A31, capital A32, capital A33. Now, adjoint means transpose of a cofactor matrix is called an adjoint of a matrix or adjoint matrix. Now, adjoint related by ADJ is adjoint of matrix A. Now, coming to inverse of a matrix here. Now, inverse of matrix formula is A inverse equal to 1 by det A into adjoint A. Here clearly det A is not equal to 0. Det A is not equal to 0 means what is which matrix compulsory? Non-singular matrix. For singular matrix, det A 0 means what will happen? Anything by 0 is infinity. That means inverse does not exist when matrix is a singular matrix means. All are clear? This is the formula for finding inverse of a matrix. So next, few formulas remember useful for competitive. So first one, A is square matrix of order n and A into adjoint A equal to adjoint A into A equal to det A into I. I means you can take based on the order n. N is the third order identity matrix. N means n will take based on it. Next, second one. Same, A is a square matrix of order n. A is square matrix of order n. And K is a scalar. Then det of K into A equal to K power n into det A. A is a constant into matrix determinant values k power n into det A. Next, third one. Same, everything A is a square matrix of order n. Then A is a square matrix of order n. Then det of adjoint A equal to det A whole power n minus 1. It's already there in P also. Det of adjoint how to get? From this formula it can be easy. Next, fourth one. Same concepts. Det of adjoint A whole power n minus 1. Few conditions are right in this first one. Second one, if you want to find det of adjoint A, the single adjoint A got det A whole power n minus 1. Here two terms, that's why det A whole power n minus 1 whole square. For example, one more you want, det of adjoint A. Here how many terms are there? Total 3. Adjoint of adjoint. Now what will get here? Get A whole power n minus 1 whole cube. Like this, I can up to n adjoints are there. Get A whole power n minus 1 whole power n will get. All clear? Any adjoint, any number of adjoint given that many times. Get A whole power n minus 1 power will come. 2 adjoints square. 3 will come out. 4 means 4 will get. All clear these concepts? Next. Coming to fourth one. If A and B non-singular square matrices, then det of AB equal to det A into det B. Or I can write this symbol also. How to write? Det of AB equal to det A into det B. Next, one more. If A is non-singular square matrix, then det of A inverse equal to 1 by det A. If it is non-singular, det A numbers are not equal to 0. In that case, so this is possible. Det of inverse matrix and det A is reciprocal to each other. Next, det of A dash equal to det A only. A dash means transpose matrix. Transpose matrix determinant and general matrix determinant both are same. It's simple. We can write like this also sometimes. Det of A dash equal to det A. Both are same. No changes. Next, one more. Det of A power m. We can write det A whole power m. Both are same. M is a positive integer. M is a positive integer. Det of A power m equal to det A whole power m. Both are equal in its values. These are some basic formulas you should remember in this case. Come to the next one, 8th one. Invertible matrices. What do you mean by invertible matrices? In this case, you remember if A is any square matrix of order n such that B is any other square matrix. Then AB equal to BA equal to I. AB, A into B, or B into A, both gives identity matrix. Then this B matrix is the inverse of A matrix. Now B is inverse of A, that is B equal to A inverse. When you write B equal to A inverse, if you replace in the place of B, A inverse, what will get equation? A into A inverse or A inverse into A equal to identity matrix. From this, what you will learn? The product of any matrix with its inverse. That product always gives identity matrix. And one more thing here, one formula we can have here. When A and B are square matrices of same order, then AB whole inverse equal to B inverse into A inverse. For this proof also there in matrices theorem, AB whole inverse equal to what formula? B inverse into A inverse. Next, how to find the product of two determinants? Now this concept is not there in PU. Now we know how to find product of two matrices, but we don't know how to find product of two determinants. For example, just how to find means the sum of product of first row, the corresponding elements of first row with first row only. Corresponding row with row only, not row with column. In matrices we will do the sum of product of elements in first row with the first column, first row with the second column, first row with third column. But here we need to multiply sum of product of corresponding elements of row with row only. First row with first row with second row, first row with third. Similarly to column wise also. First column with first column with second column like that. By example you can understand easily. I'm taking two determinants. Total. First I am taking simple. A1, B1, A2, B2 for easy purpose. Second one I am taking C1, D1, C2, D2. These two product will get defined. How we are doing for 2 by 2? For 3 by 3 are the same concept. What I said, row with row only. Remember again, it's not first row with first row and first row with second row. What you will get? Corresponding elements we need to multiply and add. A1, C1. A1, C1. Again we will get determinant only. Product of determinants we will get again a determinant. A1, C1 plus, here what is the corresponding element? B1, A2. That is the first element you will get in the determinant. You want in the same row, second element. How to get? First row with second column. A1 C2 plus B1 D2, or first row with two rows. Now coming to second row. Second row with first row in the second determinant. Second row with second row in the second determinant. Constant. First A2 C1 plus B2 D1. A2 C1 plus B2 D1. Now, second row with first 4. Next, here. A2 C2 plus B2 D2. This is a method of finding product of two determinants. Next, how to differentiate a determinant? Is a function is given, the determinant function. Differentiation of determinant. How we will do determinant differentiation? Integration of the same concept. And already some basics there in limits and derivatives. How to differentiate a function like that. Based on that I am telling delta of x. Reason why I am taking x here in this case, here the determinant value in terms of x variable, the form of function. For example, I am taking here function is f of x, first row g of x, h of x. For second row also there some other function, some a of x, b of x, c of x. Third row some constants, small a, b, c. Now to differentiate this, differentiating because function is there in terms of it, just differentiating with respect to x. In competitive useful one, this one we can write some delta dash of x. Differentiate. Here don't differentiate all elements of the time. We need to differentiate along a row wise, along or a column wise. Both columns don't differentiate because in two columns having, two rows having functions. Third row here constants. So row wise we need to differentiate. First we need to differentiate row 1, row 2 don't differentiate. Next time, first row, third row remain same, second row we need to differentiate. And last, third row we need to differentiate except first and second. Now first row we need to differentiate. Only first row means what? Derivative of first row. How to find derivative of f of x is f dash of x. G of x differentiation is g dash of x, h dash of x. Second row, third row I am not differentiating. Remain as is. A of x, b of x, c of x. A, b, c. Plus. Now first row as it is we need to write. F of x, g of x, h of x. Third row also no changes. Now we need to differentiate second row. Second row, a dash of x, b dash of x, c dash of x. Here third row only differentiate. Reason, third row all are constant. All elements are 0, determinant value is 0. Only function is there. We need to differentiate third also. Here one row we need to differentiate. Don't differentiate all at a time. And this is the differentiation of determinant. Now next concept, solving linear equations. Linear equations means the equations degree is 1 clearly. In this two type of equations or two variable equations are three variable equations. This type of equations having two set of solutions. One is consistent and another one is inconsistent. A consistent system of equations means a system of equations having one or more solutions. One or more means up to infinity. Either only one solution or more means what? It can exist up to infinity also. Such type of solutions we call as consistent system of solutions. Next, inconsistent. A system of equations solution does not exist. That means what? No solution. When inconsistent system if we got, there is no solution for the given system of equations. Now how to solve? Here two type of equations. One is non-homogeneous equations. Another one is homogeneous equations. These two set of two different type of equations. How to solve? First one, solving the non-homogeneous linear equations. This one we are solving by using matrix method. This is there already matrix inverse method. It's already there in PO also. In this concept, how to solve? Why it is not homogeneous? Right side values is not 0, but some values exist. The system of equations are given in this form. What? a1x plus b1y plus c1z equal to d1. And telling for 3 variables. Tell you 2 variables also. a2x plus b2y plus c2z equal to d2. a3x plus b3y plus c3z equal to d3. In this we will write 3 matrices. One is coefficient matrix, called A matrix. Each equation coefficients of expression A1, B1, C1, A2, B2, C2, A3, B3, C3. Next we will write the solution matrix or variable matrix X. What? X, Y, Z. Last constant values. What here? D1, D2, D3. Now after writing like this, the system of equation what it becomes complete. This equation we can express. Now this we can write in the form of Ax equal to B. From this solution means which matrix we need? X matrix. How to find directly? How to find this X matrix? X is equal to A inverse into B. To find X matrix, we need to find the product of inverse of A into B matrix. From this we can find the solution of the given linear equations. And there is some conditions we need to follow. Based on determinant value, delta of A value, the solution will be different formats we get. First, if det A is not equal to 0, then system is consistent and having a unique solution. Unique means only one solution. And coming to second case, second condition. If det A is equal to 0, det A equal to 0, the solution not exist. What in that case what we need to do? There are two verifications are there to check if this is consistent or inconsistent. In this case, we need to calculate here clearly A inverse does not exist. When A inverse not exist, we can't find X value also. Now in this case, we need to calculate few values. Now in this case, we calculate the value adjoint A into B matrix. Again, this is the matrix one we will get. Here is again first point. If adjoint A into B is not equal to null matrix, then system is inconsistent. Inconsistent and has no solution. Here remember adjoint A into B matrix is not equal to null matrix, then system is inconsistent and there is no solution for it. Second condition, if adjoint A into B is equal to 0 matrix, then system is either consistent or inconsistent according to has infinitely many solutions or no solution. When in this case adjoint A into B is null matrix means system is constant. When constant, solution is how many will come? Infinitely many solutions. If it is inconsistent also, both will be applicable in this condition. Inconsistent means solutions not exist or no solution. This is the conditions we need to follow in matrix method. Next, solving homogeneous equations. Homogeneous linear equations. First of all, which are called homogeneous equations? The system of equations in the form a1x plus b1y plus c1z equal to 0. Right side values will divide 0 1 always. a2x plus b2y plus c2z equal to 0. a3x plus b3y plus c3z equal to 0. Here also we will write three set of matrices. Coefficient a1, b1, c1, a2, b2, c2, a3, b3, c3. Next, x matrix x, y, z, and B matrix clearly a 0 matrix. Now, this combination of these equations we can write like this: Ax equal to a 0 matrix. This is called an homogeneous linear equations. Ax equals some B, some non-zero matrix, that is a non-homogeneous equations. Now, here clearly, first of all, in this we need to learn one more point here. What is meant by trivial solution? Trivial solution is simple. X, y, z all are equal to 0. That is called an trivial solution. Otherwise, it is called a non-trivial solution. Now, in this first case, if that A is not equal to 0, then system has trivial solution and unique. Unique means only one set of solution. That solution is what here? Clearly x, y, z all are equal to 0. For trivial solution, determinant value is not equal to 0. Second case, if that A equal to 0, then system is a trivial and a non-trivial also, both. Then system is non-trivial as well as trivial. Both possibilities are there. But one point we need to remember, when the system of equations is not trivial, we need to consider that A is equal to 0. Maximum question they are asking based on this condition. Non-trivial equations. Non-trivial means we need to formula what here? That A equal to 0. This is a simple way of solving homogeneous